Hey,
Hey,
is your
John.
oh good. Your audio is working.
Now it is. Okay. How's it going? We are the first ones.
Yeah, I guess so. I checked the HackMD. I didn't see other people um joining yet.
I think it's just people drop by. So if I didn't completely screw up the time, we should be actually good.
Cool.
Or maybe I did screw up the time. Well, no, then we would see something in HackMD.
Yeah. Interest. Oh, it says time 1700 GMT, 1300 EST. It is 1300 EST, but it's not. It's 1800 GMT.
Right. I was thinking about this at the very moment as well.
Yeah.
But that would mean there would be already something in the backlog, maybe.
Yeah, yeah. Well, someone else just showed up, so good sign.
Oh yeah. Okay.
Hello.
I had to get my Zoom set up again working. Always when I have a Zoom meeting, I'm like, go panicking. Damn, how does it work again?
This is the first time in a while it has not crashed for me on Wayland. I maybe the last update did good things.
I was using the phone because I'm just, it wouldn't probably work on the computer.
Yeah, well, I tried 15 minutes beforehand expecting the worst and it hasn't crashed yet, so stayed on the computer.
Oh, hey, Brandon.
Hello, hello.
We were wondering if we missed maybe the right time or something. But it's good to see you, so it's the right time.
Yeah, right time. And sometimes people show up a few minutes late. And today I'm probably in a not too quiet location. So I'm probably going to stay on mute for most of it.
I invited John Erickson here, so we want to maybe retake the questions about Nix again or get some momentum. There's things going on in the community.
That was pretty cool, Brandon. You had the
Yeah.
How did you do that? one over mask. I love it.
It's a new way of doing the background. You just background yourself instead.
That was pretty cool. Jealous I am.
Recorded.
Hey, Jace.
Hello.
So this might be close to what we're going to see for a quorum. So I think it might be worthwhile turning it over to the next folks and see, take it away.
Yeah, so hello everybody. Today I already was in this meeting, but I don't think I only remember Brandon like 6 months ago or so. And in the meantime, the Nix community has been thinking out quite with increasing intensity to connect some of their good stuff to the good stuff that the OCI framework is offering. And actually that's happening in multiple directions. And Brandon, I just recently saw that you did a SLSA implementation Go for Nix. And I was like, well, isn't that the same Brandon? Yeah, it was. so essentially, there are a couple of folks in the community starting to think out louder and louder about a way how we can incorporate maybe the Nix, well, not actually Nix way of doing things, but how we can incorporate Nix into the OCI layer semantics. And last time we have been discussing a little bit like, okay, what are the characteristics? Well, Nix layers don't ever conflict. So we don't have the problem with overlay FS. We don't have to compose it and things like that. And then, but then there was, I think there was somebody in the team in the meeting who had experience with GUIX and was sort of the question, yeah, but if we do something in the direction of Nix, what about GUIX? What about OS tree? And so that is sort of where I guess the discussion was at that point. And today I wanted to invite John Erickson because John is really one of the core contributors in the Nix community. So if there is anything on the Nix side that needs to happen to bring the two ecosystems together, I think there isn't any better person to actually make that happen. So that is sort of where we are coming from and what has happened. Well, on the concrete idea, the discussion has been going on and what could we do and how could we incorporate things. And Brendan, last time you draw a nice little kind of picture about in I think it was Draw.io, how this may even look like in theory. And what we realized is really that the Nix, hello Nisha. So Nix has these hashed store paths, which means since they are hashed, they are actually not content address, they are input address. So everything that goes into a package is sort of pre-evaluated and then the store path is calculated and then you know the path. And it has this weird format, which is reproducible, which is called nar. It's a tar, but it's reproducible by just removing things like timestamps and these type of things. So give me a second. I need to close a window here because, sorry. So, but then John said, hey, forget about this. This is really just an implementation detail and we don't really need to care about. So what we are actually left with is a system of store paths that represent binaries or whatever dependency it actually is, could be a file. And those don't conflict ever. So we don't have to deal, like in the run C, for example, we wouldn't have to deal with the overlay assembly. We could just take the path and copy them once over the other. There would never be any sort of conflicting operation, anything that would have to be removed. It's just taking a bunch of store paths and copying them into the image. Granted, we wouldn't have a typical file system hierarchy, But that's also not needed because there is a twist to the story, namely that in the Nix spectrum or in the Nix community, in the way Nix works, there is a patching of library loading. So all binaries, everything that is in the Nix store knows how to find things in the Nix store and doesn't usually depend on the usual file system hierarchy. So what does it mean for the OCI side of things? And really, if you go down and think what is the core aspect here, and probably that is nothing more than a non-conflicting predicate on the layers. So if we can say a layer is non-conflicting, we can just fetch whatever it is, put it wherever it needs to be, and tell the overlay or the runC or whatever it is to sort of bypass whatever it does.
Can I ask a clarifying question about that? This sounds awesome, and I don't know nearly enough about Nix, so this may be a dumb question. You're saying that each layer would report as being non-conflicting in some way. Is there any way that you would mix conflicting and non-conflicting layers, or do you need to just say all of the layers I'm about to give you, none of them will conflict? Or is it like certain pairs of them, these three won't conflict, but they might conflict with the fourth?
As long as they are under /nix, they can never conflict, except some other malicious actor would claim that namespace on the file system. So everything in /nix wouldn't conflict, but if somebody maliciously decides to, and I'm saying maliciously, it's probably a strong word.
Yeah.
But if somebody decides to, hey, I'm going to write things into /nix, and he happens to have calculated the same hash, then they might actually conflict. But in and of itself, everything that is under /nix would not conflict with something else. That doesn't assume that.
Would it, thanks, that sort of overlaps with the next question I had, which my general question was going to be, can we just say this whole image will contain non-conflicting layers? And that way it's clear, it's easy for, there is no, the problem is that one layer not conflicting doesn't mean anything about what it will or will not conflict with. And it sounds like in practice, you want to say.
Well, we probably can do that.
Yeah.
However, I found in work that it is useful to have a such constructed image, but then when it goes to developers, they can still do from whatever. And kind of do their thing, right? It's still sort of there. The only thing how they would connect to those binaries would put them in the path, and they are there. So
yeah. So the layers would say that they are non-conflicting for this path.
Correct, for this prefix.
Okay. That's I think that's the thing that needed to click in my head. The other question that I had and related to that was, again, not like necessarily maliciously, but probably I wrote a bug that two things do actually conflict, even though they say they don't conflict. Would you expect the runtime pulling that, trying to make the file system coherent? Would you expect that to fail, or would you expect it to be validated somewhere else?
That should awfully fail, in my opinion.
Okay, yeah.
So
loud and clear and explosive.
If I may, you could think about having layers that only have a single subdirectory or chain of subdirectories, and then they have some sort of discipline of saying they're mutually non-conflicting. Or you could say you're just going to not mount the layer at root, but mount the layer at a path. And then it's by construction non-conflicting so long as all those paths don't overlap. So I mean, it works either way, and we can definitely make a Nix side work either way. But I sort of think if overlay FS is like the sequential composition of layers, this, like as implemented today, bind melt, but sort of good to conceptually think of it that way too, would be the parallel composition of layers. So it's less about the layer itself than where you put it.
A friend put it this way: it makes a sequence a set. And that was his statement about it. I think that encapsulates most of it. I don't know who was Nisha.
Yeah, that's me. Sorry, I played around with Geeks and tried to create a container out of the resulting store. It works. So I guess maybe I missed the previous parts about what the motivation is to use container layers. It seems to me like you could build a store that has the required paths set by an environment, and then create a container from all of that information.
Oh, yeah, this goes back to last time, actually. And thing that we've been looking at is that when we synthesize the current container, we duplicate pretty much data. So imagine on every commit, we end up having a container, and that container doesn't have really overlapping pigeonholes in the 120 layers. So we end up on every commit a gigabyte. And then at some point we garbage collect, etc., and we do stuff, and we do even chunk deduplication on the file system layer just to bring that down. But then again, we already have that data as binary data or as layered, but set layer type data in the cache. So it would be a whole lot of deduplication. And obviously it would, as an ecosystem value, bring both ideas closer together. Like, I think it's very valuable to get the Nix folks into the tune of OCI, because it's like Docker, it's like enterprise, it's like not something that we want to deal with. But if we open up that door, then it's kind of a lead for the ecosystem to catch on that hook. And it probably is also for the OCI community an interesting thing to think about non-conflicting layer type, which is really all, because we have been speaking about Griggs the other time. We were thinking about, okay, can we make it somehow Nix agnostic, like tool agnostic, and say just it is a non-conflicting layer, so it could work for Griggs the same way.
Yeah, I'm just wondering if that's something that Nix can solve, because it seems to me that that's a packaging problem. So rather than create a whole store, create bits of the store that you can then assemble together. So that reduces your caching issue. And then you can, I mean, the assembly basically is just a distributed package, right? The container image.
Mm-hmm.
Have you thought about it that way? So other folks like Cloud Native build packs, they do this, where they basically keep tarballs for different capabilities. And when they're building a container image, they just reuse those tarballs.
So
I think
comparing this to what the build packs are looking at, I think what they're seeing on the Nix side is, instead of packaging together a whole chunk of code, since they're doing individual binaries, they're hitting the layer limits when they start to go through it. They just package it without doing anything else fancy. So
yeah, I mean, it's like you're, rather than using the layers, Nix already has the ability to assemble a whole tarball with a certain capability. And Docker is just like the final, convert this into a container.
yeah, so the goal I think they're looking at is not use Nix as part of your build and then create a layer that's got all the different components in there, but make Nix part of your package repository. And so that you're reusing the same the same individual Nix packages across multiple of your images.
Yeah, and I mean, Geeks Pack already does this, which is why I'm wondering, like, okay, is there something that I had missed in that process, or?
That is essentially what we're currently doing, right? So,
Yeah.
but it sort of stops short of a really good embracing integration, which is a little bit of the proposal that we're putting forth here. And I've brought John Erickson here. He's the core maintainer in Nix. So if there's anything on the Nix side that we need to do to make that marriage between the ecosystem happen, he's probably the one who can make that happen. So today I wanted to kind of renew that interest and bring the idea forth that we have come to a point where we can say, we can make a store layer that is completely agnostic of anything. The only predicate that it would have is it's non-conflicting, which could be a new type of store layer. It wouldn't have any knowledge of Nix or GUIX or whatever. It would just be non-conflicting. It would have where to fetch things and where to put them on the file system. So that is essentially what it would do. Maybe it would be non-conflicting plus a mount point. I'm not entirely sure now. So that could work in every direction. So Nix would be just one consumer of that, right? And John, maybe you can say how Nix could be made agnostic and how these are the things that we've talked previously are actually implementation details.
Right. I mean, so just so we're all clear, I don't actually know that much about OCI. What I do know is that Nix today is needlessly bespoke. And I definitely want to offload sort of crummy implementations that are in Nix itself to real, much higher quality things that other people have written, and only make ourselves different in the ways that actually matters, and not just the way we've incidentally evolved differently and not invented here and all that. So yeah, for like, if I'm understanding OCI correctly, which I, again, totally not be, the big value proposition is A, it does all your sandboxing for you, and B, it does your assembling the different things you need for you. So if on the Nix side, we're constantly baking everything together into one layer, yes, you could do that, but I think that would mean we're not getting everything that OCI offers, and we'll have our own sort of crummy, hand-rolled, flatten the things, make a tarball implementation that would just become a new bottleneck and a new reason to be tempted to do everything not invented here again. And the hope is that as we are like increasingly fine-grained without compromising on sandboxing versus, I don't know, in the more mainstream world, maybe you've got like very fine-grained Bazel rules, but like extremely coarse-grained Docker images you're running Bazel on. Whereas we want the every rule to be its own sandboxing, just as fine-grained, and it's likely no two of them have exactly the same dependencies. So there's very little reuse if you do bake everything. It'd be wonderful if OCI could just solve that problem for us, and we can just throw at extremely fine-grained layers at it, and it can deal with it. Maybe that is just something that's out of scope for OCI, and that's fine. Or every time I say OCI, I suppose I mean an implementation of the interface, but hopefully that's clear. But yeah, if anything, that the sandboxing in Linux is not too hard, but it's the manipulation of the data that we're most naive at.
Yeah, what OCI is going to bring to the table is we've got three main specs out there. The distribution spec, I think, is going to be relatively unchanged about what we're doing, because what Nix does fits very nicely within OCI of saying push a blob up, pull a blob back down. Possibly when we change the manifest a little bit, maybe we have to touch that, but hopefully not too much. The image spec, I think, is going to be the big place that you've been looking at in terms of how do you define these layers as being the non-conflicting layers. And so how do we change the image spec to be something that you can use on your side? And the other half I really wanted to ask about was the runtime spec, because that's the one that says, here's how you take this image that you're finding out with this manifest and all the description and turn it into something you're going to run. we've got runtimes out there now, and I'm curious of is, are you making your own runtime? Are you going to modify the spec somewhat for your side? What are your thoughts on where you're going with that?
My question would be right back, like I assume, and I've seen something in the chat, I'm on the phone, so I wasn't able to read it in detail, but my assumption is something in or around the runtime would do the assembly, and something there around there does the overlay. And the overlay is probably not really fast. So, or it is at least compute cycles. So would there be a way to say, if this is non-conflicting, then just do copy and nothing else? Like whatever that actually means, but just take it and copy it, and maybe in one layer, and didn't do the overlay after that? Or if there is no else overlay, then it's just going to be one single layer, or overlay at all. It wouldn't, I really don't know. I think compatibility is still key, so we shouldn't kind of ignoring the value of overlay. And just as said before, if I give that image to a Docker, to a developer, they still want to do from whatever and add stuff, right? The traditional way. It would just be a way to really do the Nix base image really cool, and then have it on one single layer, and maybe leave it with that for production if it's okay.
Is there any value in clarification from my point, because I don't know the answer to this, to saying, here's the normal layer, here's a set of Nix layers where it packs together a couple of things, here's another normal layer, here's another set of Nix layers, and they're distinct? Or would you basically say, no matter what, when we start seeing some Nix pieces in there, they're all going to get conglomerated into one layer?
Yeah, all one layer. It doesn't make sense to not collapse them, actually.
So at that point, yeah, you're looking at how do you assemble that into the layer, which means, and there's chatter going back and forth of whether or not the runtime has to get involved or not, where that border lies. But yeah, that's
the question is probably who does assemble the thing? Is that the runtime, or is it something outside the runtime spec? I'm currently not 100% clear.
That is the runtime. It's not in the runtime spec, but it is the runtime that does that. So run C does not, container D does.
Okay.
And it's not just owned by the runtime. There's also, Kubernetes does volume mounts into that same rootfs. So that would also be applicable, that you would have to make sure those volumes don't overlay your paths, right? It's sort of an issue of permissions and what kind of file system would support, half of it being overlaid and these paths not being overlaid. And how would that be set up? Doable, I think. You got Derek on. He might be able to chime in.
Not sure.
Yeah. So investigation required for sure.
I thought maybe the right point would be start to make sort of a pull request or something really tangible to the image spec, and think really about what it would mean for the image spec. And I think then naturally the other questions would come up and be directed to the right places.
It might be a good place to get the discussion started. We'll probably hold off on merging it until we can start to see someone implement it on the runtime side. And so it's going to be a combination of the two, of saying, here's a change of how we define the image, and here is someone that's actually doing it and showing that it works.
And then probably for all this to percolate, this is a 3, 4, 5 year process, I assume, or even longer, right? I don't know what the time horizons is, but I'm bracing myself for really long and slow processes.
We try to go quicker, but sometimes things do take long.
Prototyping in hand will definitely help.
Have you been talking to people that manage the runtimes, folks like Containerd or anybody like that? Or are you making your own implementation of this on the runtime? What are you looking at for that?
I thought maybe a way would be to take the runtime and make a patch manage that with Nix in our infrastructure and see how it goes. And then if that patch turns out working, but I hear that there's containerd. So if I want to target really rollout of this, it looks like we would be looking at run C and containerd. No, wait, just containerd, right? Well, I'd have to look at the details, right?
Both.
Both,
Yeah.
yeah.
I suspect most of your work's going to be containerd. If you're looking at other ones, cryo, or Podman get into that. Figure out the different.
You might be able to make it work without hitting run C.
Yeah.
So starting with containerd would probably be a good idea. Or cryo.
And you don't have to implement it in every one of them, but find one or two and see what it would take to make changes over there.
Okay. Well, this is good because I know some people in Nix have already started kind of thinking about this, but probably being shy of showing up here. I'm not, John, not you. It's, I don't know the name. I had a chat a couple of weeks ago. So I guess also a little bit of, John, we can probably take back the OCI folks. They're really welcoming and friendly, and it's no big deal to show up and discuss things here.
If it makes you feel any better, David, I was shy to show up at any of the Nix groups as well, because I had broached this idea like 3 or 4 years ago, and then I was like, okay, these people are too smart for me. I'm going to back up.
Well, I think, John, you have put that really well. How did you say it's needlessly
bespoke?
Bespoke, yeah.
That actually was something I appreciated, because that was my biggest problem on trying to move the conversation further, is that the learning curve for Nix and Geeks is very steep. And because, Geeks in particular, the code is written in Scheme, and what is it? Is it Haskell that it's based on? The functional programming language? I forgot.
Possibly.
It is inspired by that a little bit.
Yeah. So, so the learning curve is steep. First, you have to figure out like the functional programming. You have to know functional programming. Then you have to know how you write the definitions. And then you have to figure out like how to put them together. I worked with Yocto too. So in the end, it ends up being really complicated. And I think what you're looking for from OCI and just the container space is to make that easier for folks to adopt and use.
And
probably, am I getting that right?
Yeah, and probably plus that from the OCI perspective. I mean, on the Nix side, I think it's 80,000 plus already packaged binaries with decently up-to-date sources and everything keeping self-updated. And from GUI's side, I think it's another 20,000. So that would probably even beat Alpine or whatever is currently the name of the game in terms of up-to-date and availability and wealth of packages. It's really astonishing. I think Nix is currently the most up-to-date, Nix packages, it's a different thing. It's just the packaging repository behind it, but it's probably the most up-to-date package repository out there if you look at Repology. So that's really a big thing. You can just get almost any package really cheaply.
Yeah, I don't see any of the chain guard folks here, but that's precisely what they were doing with the Wolfie, is use Alpine binaries and assemble them together to form like root FSs for a certain purpose. But what we found out like 3 years ago is Geeks Pack does basically the same thing. The only issue is that you have to convert from like /GNU/store into a file system that the runtime understands, I guess. Linux, or you have to, I put in the chat, you have to create symlinks to the places where the runtime understands. So you have to create a symlink to the binary, like the shell, and then do like a Docker run or whatever.
Yeah. Sometimes binaries have hard-coded assumption about the file system hierarchy. Sometimes it's working without it. Sometimes they don't. Yeah. Brandon, you said maybe it's as simple as. I thought maybe there's a way to say we have a non-conflicting image layer towards an index, or towards a prefix. So that would make it very open to sort of any other non-conflicting file system organization out there besides of Nix, and saying, okay, this is a layer who's going towards the /Nix prefix, and everything that has this predicate is going to be non-conflicting amongst each other. Well, it would be amongst other as well, but it would encode at the same time the prefix and what it sort of claims, and then we have a way to fail early if something else happens that would contradict that claim.
Yeah, I was thinking along the lines of, if you have an annotation, and you can put annotations not just on the overall manifest, but in the layers within the manifest. And so each one of those layers, if you put an annotation on one of the layers that said, I'm non-conflicting for the path /store or something like that, whatever the path is you want to create for this. And the runtime can see that it's got 4 or 5 of those layers in there. It could assemble all of those into one of those, pseudo layers at the end of the, pulling the image down. It could assemble all those into one of those little pseudo layers at the end of all the other overlay AFS things. And that way it knows that it's not going to have any conflicts. If something in the base image put something in that path that you didn't like, you would overwrite, because you would be the last overlay on top of everything else. So I feel like there's potential to make this really easy to implement without any changes on the OCI side. It just needs to have runtimes that pick up on that annotation and sees, okay, that annotation is there, is for that path. Let me take these extra steps to implement it.
Oh, so use the annotation as a transport communication, sort of. Okay. It sounds interesting. And probably that's a good enough prototype.
It is our free-form place you can put things that already exist, that's already defined. You do have to potentially worry about other people using it, but anything that's under the OCI namespace, we technically own on our side, so we can say what that means. And then it's just up to runtimes to pick up on it. And the nice part, if the runtime doesn't pick up on it, this could look exactly the same as any other image out there. And so it could run it, and your potential is just that you run out of layers. But otherwise, as long as you don't run out of layers, you would have something that's fully backward compatible.
Okay. Yeah, I also wonder, the implementation might actually be easier than we think. It's also my feeling.
Yeah, that sounds really good. We can just maintain a patch or something, use that reserve space, and then if it starts working really well, then return to standardization with the up and running prototype. Great thinking.
Yeah, I'm on the Slack already, I guess. That's why I've asked if it's okay that we show up. So Nisha, happy to sync up with Joshua.
Yeah, so he's he calls himself the founding engineer of the Yocto project, but is like super interested in this subject. So I can introduce y'all to him.
By the way, we are not on IRC anymore. It's Matrix in the meantime.
Oh, yeah.
But similarly, it's not Slack. That has evolved. All right, I think from my perspective, I don't know, John Erickson, if there's anything that we want to add. I guess that was a really good touch and feel also for you to kind of, and we bring that message back that you're friendly people and you can show up here.
Yeah, I have nothing else. This is really great. Definitely second all that, and excited to meet Joshua and also scrounge up those people on the Nix side David's been referring to, get them to show up. So they know much more about OCI than I do. I know that.
One interesting fact, I know a friend of mine, what he did, he made a base container image with just NICs in it, and then he just faked the assembly during the runtime. So he did that inside the container, and he consistently got the startup times down. I don't know by how much, but noticeably. So what he found is that can be actually faster to start up. And the only conclusion we had was like, maybe it's because the overlay FS is not so much involved, but we don't know. I mean, the experiment just stopped there. But it was an interesting experiment, kind of. All right.
Yeah,
thank you.
If you're making the rounds looking for people to chat with, I think good set would probably be, and I'll defer to Mike Brown to tell me I'm wrong, but it might be to take some time with the Container D people and see what it would look like on their side.
Okay, Mike, you were on the Slack, right?
Yeah. If you open up an issue or get up or jump on our CNCF Slack, we can chat about this. This is interesting.
John Erickson, how do we get you on that Slack? Is there? I know we had some procedure. I don't remember.
Yeah, I'll jump through all the needed hoops. Just someone tell me what hoops.
Yeah, we've got a lot of people that are interested in this space, so and it's going to impact some of the lazy, image loading that we have. So
that's great.
It'll be an interesting discussion, but I think it's doable, and I linked showing you a place where we can already tag paths as being, non-modifiable, and I guess with Brandon's suggestion. And that, by the way, the non-modifiable will make sure we don't have issues with when they create the next container of creating a layer that overlays your stuff. If you guys are building layers that already don't, a base image that doesn't overlay itself, then we're probably okay if you're not asking the runtime to ensure that if we mark your paths as being non-modifiable by the container. I don't know. But anyways, it's an interesting subject.
By the way, Mike, some of the ones who have been trying to do things here from the Nix community, they were thinking about hijacking C standard chunked in order to annotate the metadata and get that information there. And I was like, no, let's go back to the meeting and have a chat first if we can make this somehow less hacky.
Yeah. I'm not a file systems expert. That's Derek. but we get and he's got people he can point to as well. But yeah, get on our chat and we'll find the right people for you in Container D.
Cool. Really
cool. It's already bridged to Matrix. Your website says.
I'm not sure if the bridge is still working, but let us know if it's not, and someone can double check it. That's at least for the OCI side. The CNCF is over on Container D is over on the CNCF Slack. So multiple Slacks, multiple different parties here. From coordinating the NIC, from understanding the NICs part, when it's assembling all this together, is my understanding correct that there's like a NIC store that's on the local machine, and then you collaborate a bunch of those into one usable path or something like that using hard links? Is that how it does things under the covers?
Originally, there was just no sandboxing and just different things go in different paths, and don't guess the hashes don't know about. And then now with sandboxing, it'll start with like a blank mount space and bind mount just the ones you're supposed to be able to access. So everything is by mounts, file system wise. And I forget the other things you mentioned, but
I was wondering if it was hard links, but if mounts would give kind of similar idea.
There's no hard links for sandboxing purpose. We do some hard linking for deduplication, but that's you can ignore that.
Yeah, I'm trying to think of what the implementation looks like when you try to build those layers for something like Containerd. And if you can you do, well, of course you can, because you can do volume mounts in there. So I was thinking the overlay FS combined with one of the layers that has a whole lot of bind mounts in there, I think that'll still work.
We've been doing bind mounts kind of in some previous implementation for the Nomad runtimes. Actually, it was nspawn, I guess, yeah. And they were just bind mounted all the layers into that thing. One benefit of sort of doing that, but I don't know how this would look like, is that you may just on the host having these stores also stick around, and then you don't have to download them again. So it would kind of double up as a cache. I'm not sure that's already the case, I guess. So yeah, I need to look at this in detail.
That's kind of my goal, because that's what happens with layers today, is when you pull down a layer, something like Containerd is going to see that it's already pulled that layer down before, and it's not going to have to pull it down a second time. And then it's just assembling all those as a bunch of overlays. And so it just picks from its store, pull these 5 different overlays, to, layers of an overlay together, and assemble one of those for the container. So extending that to have an extra store in there for the next side of it will be interesting.
Yeah, that sounds great. All the least recently used type logic about caching local copies of things. We want someone else to do that way better than us.
Very cool. Well, hopefully we gave you some thoughts on where to go with this and potential next steps. Folks to talk to.
Yeah, absolutely. I just hope the chat won't disappear after, so I can, make sure I have everything copied down. This was super useful, and really appreciate your all time.
The Zoom chat does go away, so grab whatever you want out of there now.
Okay.
And if there's something important, feel free to copy or put in our meeting notes, and the meeting notes in the HackMD do stay around.
Cool. I'll get started on that right away in our last 10 minutes or so. And I don't think there was anything else on the formal agenda. Was there anybody that had other things they wanted to bring up today? Cool. Well, if there's nothing else, we can all jump off. You can stick around here and keep pulling things out of the chat message at your own pace. We're not going to rush you out of here.
Oh yeah, but, that's what I'm doing.
Did you want to talk about the
oops,
the
I
versions?
didn't. Sorry, can you hear me?
Yep, go ahead, Nisha.
Yeah, okay. Sorry, I had muted my microphone. I was gonna ask if the auth working group had spun up yet.
The proposal has been submitted to the TOB. So I think we're waiting for some feedback from the TOB, which I think, Nisha, you might be on that. And
I thought there's like new TOB coming around, but I guess that's next year. Okay.
So yeah, some feedback there. I think when I was looking at the process for doing a working group, I saw some more steps maybe we still need to do. I pretty much copied what we had done for the last working group, so they may have skipped steps, I'm not sure. But either way, I would say it's the key thing for us is to get feedback from the TOB and get other people that are interested to chime in on that working group issue over on the TOB to say they're interested in joining.
Cool, I'll take a look then. My apologies for not looking at it before.
No apologies needed. We're all busy. Mike, did you have something else you were jumping on?
Oh, yeah, we were talking about the versioning issue. I didn't know if you wanted to go into that a little bit or.
Yeah, versioning versus actually pinging the API, that one.
Yeah, that one entirely. The more we talk about it, Brandon. What do you think about the idea of actually supporting both models as a must requirement for 1.1? In other words, you would presume that in some paths, the refers API isn't going to be supported in the chain of mirrors, for example, although it may be in some other cases. And so therefore, you should probably be required to go ahead and push that refers schema image index in all cases.
So it's one of those things that's pretty easy to copy on a mirror, because you query the refers API. If it exists, you're going to get back the whole index. And if you are now pushing that to a mirror that doesn't support it, you query and say, does the refers exist? Do I see the info I'm looking for? If not, push that refers content that you just pulled down from the upstream to the next mirror as the digest tag. So you don't have to do any translation. You've got all the data you need right there.
If you're pushing to the source originally, yeah.
If you're pushing to wherever the mirror is, yeah.
And what happens if the source deprecates or falls back in support for that refers API, and now the index isn't there? And there's a lot of use cases. I'm just saying it might behoove us to support backwards compatibility with 1.1 as a requirement, as opposed to a must-have only if 1.1 refers API fails. Maybe there's another solution here. Anyways, for the rest of the audience, it's a little confusing, I think, when a client is first writing the code to figure out what it means. I'm writing support for pushing an artifact, and now I've got to go call refers to see if the registry I just pushed the 1.1 artifact to supports pulling that artifact. And if it doesn't, the current must requirement is that the client should then push an image index with this new refers tag schema. Okay. And it's an interesting little tweak there that you've got to do some more stuff at the client, but it's not clear yet what the client should be doing with users. And what if a user, doesn't want to push to a registry that doesn't have refers? It doesn't really make a whole lot of sense from a client perspective or a client user perspective that they push two artifacts and now they've got this image index that was generated by the client for them that's being pushed as well with some tag that they didn't even know about. Or that you fail and require the user to create this image index with a new tag, right, with additional client tooling, and then push that up so that they can pull these artifacts they just created. So it's a little confusing.
So I guess if you want to say that you want to make sure you're never pushing the fallback, you can always check the refers API in advance. You don't have to check for it after the fact. And your
nil option certainly makes that somewhat makes sense as a version check. And then from that argument, okay, well that's how we're going to do version checking. But it's still a version. It's just not a explicit version API.
It's an API check versus a version that you're inferring the API from the version. And right. I get concerned. And then
when we have two versions of the refers, what would be the next version check that we would add with maybe all zeros and a 1 on the end? You see, it's
no. So the response should come back, and just the fact that there's response and that it's got an image index in there says you've got the refers working. And if we ever change for a new refers, then something that new API is going to have to be visible inside of that response. So you query the same thing, but something should be different in that response. And I think, Sajay, you were probably the one that was talking about using the all zeros for the digest. Is that right? Am I remembering that right?
Yeah, I mean, that was one way to kind of get around the problem because we couldn't query the registry, right? I suggested just go with it because the spec was a little, I mean, there are many edge cases. If the repo doesn't exist, you have to check for a substatus code called error not found, or like name not found, which is there in the spec. You literally have to dig down quite a few cases to figure out that the thing is not implemented. But I want to kind of like raise up the conversation. we have tools like when you do kubectl version, it tells you the server version of what it is. Is there general interest in making the distribution spec support an endpoint that we can query, irrespective of referrers or not, and just kind of like have, because there is a magic error in there. Like if you look at it, there's a Docker version 1.0 in there somewhere.
Exactly. Yeah.
So should we standardize it? And we have these quirks, right, in these implementations. So that's what I want to kind of like raise it up to.
Yeah.
It'll benefit in general that if 1.1 is supported, okay, we don't have to do anything. And this API can be a simple head API, and we define all clients can take dependency on it, quick, fast, and not depend on a route or something like that. I mean, these are all proposals, but nothing's been written out yet.
I think it's interesting, but then we've also seen with some of our conformance checks, that we're checking individual sets of APIs. And so you can be OCI v1 compatible and not implement the tag listing.
Right. So it's version in caps.
Yeah.
It's a little bit of both. You need the capabilities of the server and what version they're supporting those capabilities at. And yeah, that might be one per API, right? So.
Yeah, I mean, so I think the point is, should we form or improve the spec to add capabilities in general? And yes, before the other thing is, one challenge that we faced during implementation is, should I push the OCI artifact manifest requires me to first query the registry to see if that capability is supported in the workflow. Forget querying the thing itself, just creating the artifact workflow was, I need to query a remote to kind of determine my workflow and create the content. Like if I'm on a build machine, I don't know whether my target actually supports it. So I think these kind of scenarios haven't been discussed, but I think that's also the point of the issue here. I'm seeing this as a broader issue, not just for referrers in general. I mean,
I liked your idea, CJ, to go ahead and do some work on the CAPS API and make it a should, but not a must. And then we can introduce that as a pattern, down the road. And I just wanted, Brandon, for you to think, or at least discuss a little bit, think about it, the idea of requiring backwards compatibility with the later APIs. For example, this 1.1, go ahead and require the push of the index because of the cases where people are going to be looking for a tag refers. Yeah.
My hope is that once registries start to support this, that clients won't push that tag, because I feel like clients don't want to see that tag.
Right. So it would be, and then immediately deprecated, such that in 1.2, you wouldn't do it that way. Once we have the preponderance of registry supporting 1.1 refers API, then we don't need the backup plan, right?
Yeah, if you're doing both, you have the refers API and the tag there. Are you worried about which takes priority, or how are you generating that tag?
In the text, it says that it has to incorporate, right, if that's pushed. So
the registry only has to incorporate what was in the tag at the time they enable the API. Once the API exists, then there's no more obligation for clients to maintain that tag anymore. We never said, and I think it's potential for a registry to implement this, where they not only import all that stuff into the refers API, but they also delete the tag. I could very well see a registry do that.
Right, and we've got a 1.6 LTS that doesn't have this in it, but we'll probably put it in eventually, which means we'll have a 1.5 release of Containerd that doesn't know what the artifacts are at all. We'll have a 1.6.10 maybe, or 11 that does, right? But the prior version won't. But some people are using it already to pull these things. It just gets more complicated when you've got multiple versions of clients out there. And sometimes you're supporting, the newer client is pushing something that's needed for an older client, right? It just gets complicated. That's all I'm saying. we might want to think about the backwards compatibility issue, for other clients. And I mentioned mirrors because they're in the path, but if you think that that's not a really viable scenario, then that's different.
No, I think it's a valid scenario, but I don't think there's an issue supporting those mirrors in the path, because as you go through that process, well,
actually,
okay, I get where you're going with that one. Actually,
I can add a real scenario that we're facing right now, which is we're supporting pull-through cache for Docker Hub and Quay. Those repositories won't have capabilities for referers API. Now, but if you're pushing to your registry, you can use the referers API. So composing is going to be challenging. So maybe if you could query for that specific repository the same way, like for referers, it's kind of solved in some way, right? Like, but you cannot push, or maybe some API is not enabled. So all I'm saying is I think mirroring is challenging unless you have standard way to kind of like at least find out what the caps are on that. So I'll add to the issue.
If it was a server-side requirement,
right,
it'd be a little different, but we're not. Yeah.
The pause in my brain was realizing that you're going from like a pull-through mirror rather than a manually maintained mirror, because a manually maintained mirror would have been super easy that whatever's doing that maintenance, copying stuff across would do it for you. But yeah, pull-through cache, it is an issue.
Yeah. Well, yeah. Think about it. It's fun talking. It's an interesting, interesting issue or topic.
Yep. We'll chat about, I'm sure, another week. To the next team, thanks so much for a good discussion today. Hopefully we gave you some good stuff, and feel free to drop by any other time.
Cheers.
Thank you very much. I hope we come in masters.